Hello, thank you for joining this technical session at Google I/O 2024. My name is Wei, and I'm a developer advocate at Google. Today, my colleague Shrestha and I will be talking to you about the exciting topic of AI-assisted coding. Generative AI is transforming many industries today. The software industry is no exception, and many practitioners are already benefiting from adopting AI. For example, in a typical software development lifecycle, AI could help you analyze user requirements and write PRDs in the planning phase. While you're designing the architecture of your application, you could brainstorm with AI and come up with new interesting solutions. When you start coding, AI could help you code faster and better. When you finally release your application to the world, you could use AI to monitor usage and analyze user feedback for future development. Let's zoom in on the coding phase. AI could automate away many tedious tasks so that you have more time to work on the more creative parts of your workflow. You may also use AI as a coding buddy to review or critique your code, and it will improve your code quality. Sometimes, AI could even bring more creativity to the table by suggesting alternative or even better implementations for you. Ultimately, taking advantage of AI coding assistance could lead to higher productivity and more developer happiness. Which is why when Stack Overflow released their annual developer survey last year, they reported that 70% of the respondents were already using or planning to use AI in their development process. And 77% of the respondents were in favor of AI tools for development. That's a lot of developers in action. This year, the numbers may be even higher. So if you still haven't used AI for coding, now is a good time to get started. AI coding assistance covers a wide range of use cases in your development process, from code completion, code generation, and code chat, to code explanation and error debugging, and so many more. These use cases are well covered by a number of Google products, since we have long been working on AI and developer tools. So let me demonstrate how they work. First, our coding workspaces, or IDEs, such as Colab, Project IDX, Vertex AI, Android Studio, and Chrome DevTools, have all incorporated coding AI. For example, here we're in Google Colab, which is a hosted Jupyter Notebook service that provides computing resources, including a usage tier available free of charge. You can use the AI-generated suggestions in Colab for code completion, based on your current coding context. Let's start by creating a simple function to compute a circles area. As I type the function name, the built-in AI is able to guess what I want and suggest implementation without me even asking. How convenient this is. I can simply hit Tab to accept the suggestion or Escape to ignore it. What if I want a class instead of a function? I can type the first few letters, and AI is again able to figure out what I want and have the circle class defined. I like this class, but in the calculation, it uses only 3.14, which is lower precision for pi. Let me change that. I know the math library has a pi value defined in higher precision, so I import that. As I'm typing, AI predicts I want to swap out 3.14 for math.pi, and all I need to do is to hit Tab. Next, let's run a simple test on this new class. I define a list of circles based on the AI-generated suggestions, but I don't like the default values, so I manually change them. I start writing a for loop, and immediately AI predicts that I want to print out the area value for each circle, and that's it. I accept this code snippet as well, and I run the last two code blocks to verify the results, and they look great. As you can see here, I have barely typed 30 characters, and AI is able to figure out my intentions and finish what I want to build. Code generation is another important use case. Instead of manually writing code, I can simply specify the functionality I want in natural language and let AI build it for me. This time, I'm using Google's Project IDX, a web-based workspace that enables full-stack, multi-platform app development workflow on the cloud. In IDX, I'm using Command-I on my Mac to invoke the inline AI and prompt it to write a function to find the non-common elements of two lists without using other data structures. IDX follows my instructions smoothly and generates the function I want. I can then accept or discard the code. To make sure my function here is solid, we need to write some unit tests, which sometimes feels like a chore to many developers. With AI, it doesn't have to be like that. I simply ask AI to add 3 unit tests, and voila, it is done automatically. Now I think our function is more or less ready, so let me put a finishing touch on it by adding documentation. Writing documentation sometimes is tedious, but it is very important for readability and maintainability. So we gotta do it. Similar to unit tests, all I need to do is to ask IDX AI to add docstring, and it automatically populates Python documentation for our function without a hitch. Sometimes you inherit code from someone else, and you need to be able to understand the code. Here, we see an example of code explanation on Gemini Code Assist. Gemini Code Assist is available in multiple IDEs such as Visual Studio Code, JetBrains IDEs, Cloud Workstations, Cloud Share Editor, and supports more than 20 programming languages, including Go, Java, JavaScript, Python, and SQL. And sometimes the code works, but you want to make it more optimal in some way. Maybe more performance, maybe more secure, maybe more idiomatic, maybe just simpler. In this case, we see an example where the underlying code was translated from Java to Kotlin using the built-in IntelliJ functionality. However, if you want to make the code more idiomatic, we ask for that transformation in natural language, and we can see from the resulting code that it follows the Kotlin style better. Event syntax, string templates, smart casts, and so on. Have you ever had any experience when the console just throws up an error and you have no clue about it? Like here in Chrome DevTools, I have no idea what's causing the issue in my Fibonacci number implementation. But I get to ask the built-in AI to explain this error, and I immediately get insight to help me debug. It seems my recursive calls are not properly terminated, so with that hint, I can easily fix it. Now, I'll pass it to my colleague Shrestha to explore even more use cases with you.
Hi, I'm Shrestha Basu Mallick. I'm a group product manager at Google working on generative AI. Now I'll talk to you about the next set of products. The first product we'll talk about is Search Generative Experience, also known as SGE. Historically, developers have used Google Search extensively to ask their implementation questions, to find out when there are errors in their code, what to do, or to find documentation. And sometimes for more open-ended pursuits, such as researching an architecture decision or learning a new skill. We have brought generative AI into Google Search through SGE. You can ask questions now and get an answer with code snippets, natural language explanations, and relevant code examples. In certain cases, the code is executed to show the results, as you can see here. The next product that we will be talking about is Gemini Chat. Developers can also ask their code-related questions here and get back code answers, use this to refactor their code, use this to explain code for them, and generally chat about anything code-related. Here, in this example, you can see that Gemini Chat not only executes the code for you, but also lets you get in there, edit your code, and rerun that code. The next product we'll be talking about is AI on developers.google.com, which is Google's main developer documentation website, which is visited by millions of developers. We have added AI capabilities to simplify the developer's journey so that the answers they get is a combination of generative AI as well as authoritative documentation from subject matter experts. Here, on developers.google.com, you will have AI search, which allow developers to quickly grasp key information from search results. documentation chat, where developers can interact with a conversational AI assistant for focused guidance regarding particular developer products and pages, and AI Code Explain, which provides a deeper understanding of code samples through AI explanations. Looking ahead, we plan to expand these AI features to other Google developer properties. The products mentioned so far are all built on Google's cutting edge foundation models. For developers who directly want to build applications on top of our code models, we have also released Code Gemma, which is our latest open code model specifically targeted towards coding tasks. Code Gemma is a family of open code models based on Google DeepMind's Gemma models. Continuing from the base Gemma models, Code Gemma models were further trained on up to 500 billion tokens of mostly code. They use the same architecture as the Gemma model family. These models achieve state of the art performance in both code completion and code generation tasks while maintaining strong understanding and reasoning skills. Code Gemma comes in two different size variants, 2 billion and 7 billion. The smaller 2 billion model is the pre-trained model with lightning fast speed, and it's perfect for the code completion use case. The bigger 7 billion model has two flavors, the base model and the instruction-tuned model. The 7 billion model requires more computational resources, but you can still use the 7 billion pre-trained code variant for code completion if you have a powerful machine. The instruction-tuned 7 billion model is better suited for the code chat use case. Here you see the example code to use Keras to run Code Gemma. We first load the Code Gemma instruct 7b model with the from preset function and then call the generate function to get the prediction. This is similar to how you would use the base Gemma instruct model, except that we are passing code in the prompt and we get a Code Gemma prediction as inference. If you plan to use Code Gemma to build AI core capabilities within your coding environment, a simple inference may not be sufficient in certain cases. You will need to know about techniques such as fill in the middle or FIM and retrieval augmented generation or RAG. Fill in the middle is a technique that uses language model to impart infilling capabilities by packing both the left context and the right context separated by special tokens. What we mean by this is when you're using code completion inside of an IDE, you sometimes have code above where you're doing the completion and below where you're doing the completion. The above is the left context here, the below is the right context here. And you pack both of those into the prompt. Feel free to check out the Code Gemma technical report to learn more about this. Retrieval augmented generation or RAG is another technique which is used to make the LLM answers either more accurate or more relevant. It can also sometimes help when you have to deal with a use case where you need a large context, such as trying to get an answer based on a large code base. For retrieval augmentation, what you do is you take the code base, you break it into chunks of code. Sometimes you can convert these chunks of code into embeddings, and you store it in a vector database. Then at inference time, you retrieve the relevant snippets of code and you add it to your prompt and you add it to your query and you pass that as prompt to the model. This ensures that the answers you get back are potentially more accurate or more relevant. In summary, Google is not only offering you Code AI innovation across a lot of surfaces, we're also making our open models available to you to build your apps on top of them. We have built all our Code AI features to serve developers of all stripes, be they web developers, mobile developers, enterprise developers, or even developers of all experience levels, such from beginners to experts. A lot goes into developing these features. We start with the right task. Sometimes a task may require building a model from scratch. Sometimes we may fine tune on top of our base models. It all depends on the task. For example, for code completion, you may want to use a smaller model because you need to have lightning fast speed. On the other hand, if you're doing code AI inside of Colab, you need to make sure that the response style adheres to the notebook coding format. Or if you're building code AI features in Android Studio, then you may want to make sure languages that Android developers care about, such as Java and Kotlin, are well represented. When we start building these models, the first thing we have to think about is the data. We use high quality, permissively licensed data, and we make sure that we sanitize the data of all sensitive information. The next step is, pre-training, and specifically if we are pre-training for a specific domain, then we would do domain specific pre-training. In this case, we train models on more tokens of code. The next step is instruction tuning. Instruction tuning is to make sure that the answer adheres to a specific style or format. For example, if you're using code chat, then you want your responses to be a little chatty. The next one is offline evaluations. Here we do a combination of human evaluations as well as automatic evaluations. And finally comes the integration step, where we integrate the model with the other components of the LLM building blocks, such as serving configurations, monitoring, safety guardrails, and of course the UX. A lot of magic also happens in this post-processing step. For example, when you're outputting a code completion response, you need to know where to truncate the response. You may do it based on what's known as a stop token, a specific token that you decide in advance, or you do it based on, say, how much of the response overlaps with the suffix or what we call the write context. So a lot of decisions like this are made in the post processing. UX, you've already seen examples in various section. You sometimes can interact with the models through chat, sometimes within your workflow inside of your coding environment. And finally, we need to talk about safety guardrails. A lot of attention is paid to safety. We make sure first, when we are coming up with the data, we make sure the data is properly scrubbed and debiased. We also take proper anonymization into consideration. Then when we have safety filters in the API to safeguard against unsafe responses, and we also show citations. Whenever we have code that requires showing the source, we make sure to responsibly show that source. Enterprise users even can block out code that requires citations. As we look into the future, we are thinking about code agents. Here, we show you an example of a data science agent that we are building. The things we want to highlight about this data science agent is that it can build notebooks from scratch with detailed plans and complex reasoning. It supports a bunch of data tasks such as data cleaning, exploratory data analysis, getting insights from data, statistical analyses, and predictive modeling. In the spirit of experimenting with the user experience, we will provide the user not just with the end result, but also provide an insight into how the agent is doing reasoning and planning. And this will be provided via a web app format as well as in the final collab that you see on the screen here. This collab that you see is entirely generated by the agent. We want to make code innovations like this available early to users through a developer playground so that we can test experiments related to functionality, related to user experience, and other aspects of code development. In this next phase of AI, we believe generative AI will become more mature and ubiquitous. The future of software development, we believe, will involve empowering developers in AI to collaborate on creative problem solving and innovation. We are super excited about this future and can't wait to build it together with you. With that, thank you for watching this technical session at Google I/O 2024 and happy coding with AI.